Hello everyone, Gaza Mutkarsh and I welcome you all to this session on NumPy for numerical calculations. So guys, let's have a look at the agenda for this session. So the agenda for this session includes array functions. We'll discuss the different arithmetic functions, namely sum, min, max, mean. We'll discuss other array functions such as argmin, argmax and argsort. And we're also going to discuss a couple of array filtering functions such as var and extract. In the previous session, so far we have discussed NumPy arrays, arrays versus list, and we have also covered let's say array reshaping, indexing and slicing in 1D and 2D arrays. So proceeding with today's agenda, let's switch to the Jupyter screen. So guys, over here we are in the Jupyter screen. So first of all, I'm importing NumPy. All right. Then over here, this is the array. Over here, I'm having this array. All right. Now, as far as this array is concerned, this is a 2D array. Let's have a look. So over here, I'm having a1 dot shape. So this is a 2D array, right? We have 4, 3. Now let's understand some of the very basic functions that we have. So first we'll be starting with the arithmetic function. The first function is sum. So considering this is the array, now as the name sounds, sum is used to perform sum of, let's say, what does it perform? It simply performs sum of elements, right? It performs sum of elements from, let's say, entirely sum of all elements, performs sum of all elements or sum of elements row or column wise. All right. So the array that we have over here is a1. Now if I were to write a1 dot sum, because a1 is an array, I can perform a1 dot sum. So the sum of all these numbers is 83, and likewise I can also write np dot sum a1. So both ways it works. So sum of all the numbers that we have over here is 83. Now there's another way to look at this function. What if I were to calculate row wise sum and the column wise sum? So let's see how to do this. So to implement this, I can write np dot sum a1 along the axis 0. All right. So when I'm writing along the axis 0, so clearly we have 3 columns, right? Now axis 0 indicates column wise. Over here axis 0 indicates column wise. So how many columns do we have? We have 3 columns. So 5 plus 15 plus 12 plus 8. 12 plus 8 is 20, and then 15 plus 5 is again 20. That makes a total of 40. Likewise 14 plus 70 plus 12 plus 20, that is again 63. 7 plus 22 plus 24 plus 27, that is 80. So guys, this is column wise sum. Now I can also perform it row wise. So I'll just have to write xs1. So xs1 here indicates row wise. So when we wish to see the row wise sum, so what are we going to write? xs1. So how many rows are there? We have a total of 4 rows, right? So 5 plus 14 plus 7, then 15 plus 17 plus 22. Let's see the results. So 5 plus 14 plus 7, 26, 15 plus 17 plus 22, that is 54, then 12 plus 20 plus 24, 56, 8 plus 12 plus 7, 47, right? So this is how we can perform row wise and column wise sum. So likewise, we'll use the concept of axis to identify whether we need to calculate to make these calculations row wise or even column wise. So next we have min and max. So again, as the name sounds, what do these perform? Let's say computes minimum and maximum row and column wise. All right, or for the entire array. This is my array. Now if I were to find its minimum and maximum, right? So what is its maximum? The maximum element that we have over here is 27. The minimum element that we have over here is 5. Now this is for the entire array. I did not use any, I haven't used any let's say excess, right? Now to if I were to check this If I were to check this, maybe row and column wise, then what would be the impact? Let's see. So over here I'm writing np dot max, and then max of a1 along axis is equal to 0. Axis 0 means column wise. Axis 0 is column wise. So what are we performing over here? As far as this example is concerned, this is column wise maximum. So in the first column, the maximum value is 15. In the second column, it's 20. In the third column, it's 27. So 15, 20, and 27. Likewise, the way we have computed maximum, I can compute minimum along the column. So this would be column wise minimum. So what do we have over here? So what is the minimum in the first column? That is 5. Minimum in the second column is 12. Minimum in the third column is 7. Alright, so 5, 12, and 7. So this is maximum and minimum along the column. Likewise, I can implement np.max a1 along axis is equal to 1. Alright, so this is axis is equal to 1, and what do we have over here? This is row wise maximum. So axis 1 and row wise maximum, let's see what are we going to get. So over here I'm getting row wise maximum. So in the first row the maximum is 14, in the second row the maximum is 22, in the third row the maximum is 24, in the fourth row the maximum is 27. So this is what we have, right? Next. So after max I have to compute the minimum, and over here I'm passing the axis as 1. So this is row wise minimum. So what do we get over here? We have 5, 15, 12, and 8, right? Over here I'm getting 5, 15, 12, and 8. So guys, I hope this is clear to everyone. So for each row I'm computing the minimum value 5, 15, and then we have 12, and then we have 8. So this is how we can work with the min max and the sum function. Likewise, we can apply the same logic to the mean. So np dot mean, and as the name sounds, let's say computes, it simply computes mean row wise, or row and column wise, or for the entire array. Correct? So let's see this. First of all, I'm printing a1. Alright, and after a1 over here, what do we have? I'm printing a1 dot mean, or np dot mean. Np dot mean a1. So what is the average of this array? The average is 15.25. Now I can write np dot mean along axis, np dot mean of a1 along axis is equal to 0. Alright, so axis 0 means column wise. So this is column wise mean. And if I write axis is equal to 1, so what do we get? This is row wise mean. So how many columns do we have? We have 3 columns, so we are getting 3 values. How many rows do we have? We have 4 rows, so we are getting 4 values. So this is how we can perform the basic arithmetic operations, arithmetic functions like sum, minimum, maximum, and mean, even row wise and column wise. So if we are implementing it for 1D, of course, we don't need to pass axis, but for 2D arrays, we need to pass axis as well. So for 1D means no axis is required, we'll only get a single value. Now, moving forward, we do have some functions that are based on arg. All right, let's call them arg based functions. So arg essentially indicates index. So in NumPy, if the function is starting with arg, right? So they simply returns the index based on the type of function that they are. Clear? So they simply return the index based on the function type. So over here we have np.argmax and np.argmin. So argmax simply returns the indexes of the maximum value along an axis, and argmin simply returns the index of the minimum value along an axis. Let's see this in action. We can perform this in 1D and 2D as well. So this is my array, right? So this is as of now this is one dimension. Now if I were to print np.arg, okay, first let me print np.max of p1 and np.min of p1. So what is the maximum and minimum? Over here we have 47, and next we have 18. So 47 is the maximum value, and next we have 18. All right. So after 47 and 18, if we were to proceed further, next what do we have? We can write argmax and argmin. So argmax return the index of the maximum value. So where do we find, okay, 34 I think is repeated. Let's change this to, but anyways, no issues. 34 is even repeating. Let's change this to 38. All right, now there are no repeat elements. So where is the index, where is the element with the maximum value? That is 47. What is the index of 47? The index of 47 is 1. Likewise, if I pass argmin p1, so what is the index of the minimum element? Minimum element is 18 and its index is 0, 1, 2, 3. All right. So this is how we can perform argmax and argmin. So this example was meant for 1D. We can also extend the same conversation to 2D arrays. So this is my array. Now if I were to write np.argmax, for argmax, now over here, let's say I want to pass xs is equal to 0, but for the array a1. Now let's understand this. This is very important to understand. Xs is equal to 0 means column wise. All right. So when we are trying to search column wise maximum value, we won't be finding the index of the column, because let's say for the first column, right? In first column, what are the elements do we have? So each of these elements has the same value for the column, right? Which is 0. So if it argmax, if it were to return the column index, it would make no sense. Now if I say the maximum value has a column index of 0, so all the elements have the column index 0, right? So it makes no sense that if along an axis we wish to find the column index with the maximum value 0, at index 0 we have all the 4 values. So it makes all the way more sense to if it returns the row index where we have the maximum value along the each column. So this is computing column wise, but what does it return? It return row index where value is maximum. All right. What is it returning? It is simply returning the row index where the value is maximum. So let's observe along the first column, along the column index 0. Where is the maximum value? The maximum value is at 15. 15 is the maximum value. What is the row index of 15? This would be 1. All right. So the maximum is in the 0th column, the maximum value is 15. In the first column, the maximum value is 20. In the second column, the maximum value is 27. So what are the row indexes of the selected values? This is 0, 1 and 2. This is 1, 2 and 3. All right, because we have 4 rows, so 0, 1, 2, 3. Please see over here I'm getting 1, 2, 3. For 15 row index 1, for 20 row index 2, for 27 row index 3. Likewise, if I were to write x is 0, but instead of argmax I'm going with argmin. So column wise it returns row index where the value is minimum. All right, so okay, let's observe this. In the first column, where do we get the minimum value? The minimum value is 5. In the second, in the column 1, what is the minimum value? The minimum value in the first column, right? Over here we have 0. This is argmin x is 0, right? The minimum value is 12, and over here the minimum value is 7. So this is 0, 3 and 0. All right, this is what we are getting. The index of this particular row is 0, index of this row is 3. Likewise, over here I can also perform np dot argmax a1, but this time along the axis is 1. So axis 1, what would it return? This is simply row wise. It will return, so when we are implementing argmax and argmin along the rows, so for the 0th row, the maximum value will be in the 0th row and even the minimum value will be in the 0th row, right? So does it make any sense to return, let's say, the row number? No. तो यहाँ पे ये आपका column number return करता है, right? This will simply return the column number where we have the maximum value. या फिर minimum के लिए भी ये minimum value ही let's say column के लिए row number return होगा, row के लिए column number return होगा. That's the basic logic we can grasp. So यहाँ पे हम we have to write argmax np.argmax a1 along axis1. So row wise it returns column where value is, it returns column, let's say, where the value is maximum. Why maximum? Because over here I've chosen argmax. So एक बार देख लेते हैं. Where do we have maximum value? This is 14, then 22, then 24, and then 27. So this will give us 1 0 1 2, right? So 1 2 2 2. Okay, I think I'm missing a bracket. So as we can see over here, the output is 1 2 2 2. Now if I were to perform its reverse, so np dot argmax a1 along axis is equal to 1, but instead of argmax I need to write argmin. So what is it going to return? This is simply going to return row wise. What does it return? It returns column where the value is minimum. So for each column, what is where is the minimum value? This is row wise, right? So for each row it has to return the minimum value. So for the first row it is 5, for the second row 15, then 12, and then 8. This is the minimum value, right? So see over here we are getting all zeros. So guys, it is quite important to understand how the argmax and argmin works along a particular axis. All right, now we do have another function which is argsort, which is slightly, let's say, more advanced. So we understand what the sorting implies, right? So argmax, argmin, and then we have this. Okay, let's change the numbers. So third is maybe mean, then let's call this 4, and then over here we'll have 5, argsort. So first let's understand what it does, and then maybe then we can proceed with the definition. So over here I'm printing p1. So what all elements do we have over here? The elements we have are 25, 47, 34, 18, 38, and 19, right? So what are the positive indexes? Over here I'll be having 0, then 1, then 2, 3, 4, 5. Correct? These are the positive indexes. Let's ignore the negative indexes for the time being. So if I were to sort this, in ascending order, right? So what would be the output? It would be 18. The minimum number is 18. Then we'll have 19. So after 18 and 19, then after let's say 18 and 19, what is the next number? The next we'll get is 25. Then after 25 we'll have 34, then we'll have 38, and then we'll have 47. So if I were to arrange the indexes now, so 18 is at index 3, so 19 is at index 5, 25 is at index 0, and 34 is at index 2, 38 is at index 4, and 47 is at index 1. So when I'm arranging the elements in the ascending order, what is the shift in the index? All right, so this is the order that we are getting. Now let's try to print this. Over here I'll be applying np.argsort, and then I'm passing p1. Observe the output. Are we getting this 350241? So how have we obtained this 350241? I've just explained over here, right? So this is ascending order. This is elements in the ascending order. Elements in ascending order. And what do we have over here? These are the positive index arranged in the ascending order of elements. All right. So guys, these are the positive index arranged in the ascending order of elements. So this is how we can apply argsort as well. Next, moving forward, we do have some filtering functions. So as far as array filtering is concerned, we have two different options, namely np.where and np.extract. So let's understand this with the help of an example. So we are done till 5. Next, we are moving on to 6th. So np.where is simply used for filtering, and there are two particular syntax. If we use syntax 1, it is simply going to return index. If we are going to use syntax 2, it will return let's say the values, those that are filtered. So considering this p1, Now I want to filter all the elements. Filter all elements. All right. Let's say which are divisible by 3. So maybe I'll write F1. F1 is the filtering np.where. Now I just need to write. So in type 1, what is the syntax? Type 1 simply returns the index position for the matching conditions. Means type 1 is just a name. Means I've written. There's no specific reference to type 1 in the official documentation. So I'm just telling you this is let's say this is, let's call this syntax 1. All right. So in syntax 1, we only write what is the syntax np.where, and we just pass the condition on array. This is how we pass. All right. So it returns index position for the matching conditions. So what do we pass over here? I'm writing p1. p1 mod 3 double equals 0, and then I'm printing f1. So guys, what are the elements that are divisible by 3? The elements that are divisible by 3 are 12, and then we have 45. So 12 is at index 0, 45 is at index 5. Correct? 12 is at index 0 and 45 is at index 5. So what is it returning? It returns index where the values, returns index where values are filtered. I can give you another example. Maybe f2 is np.where p1 greater than 10. So I want to know all the elements that are greater than 10. So we have 12, 14, okay, greater than maybe 20. So see, greater than 20, 79, 32, 45 and 28. So the indexes are 3, 4, 5 and 6. Now the same conversation can be extended to even 2D arrays. So this was my 2D array, right? So if in 2D array, if I perform np.where with this particular syntax, then over here it will return two arrays, one for row index, another for column indexes. Let's see. So over here, if I perform the same operation, I'll call it f3, and in f3 over here I'll be passing np.where, and inside np.where over here I'll be passing, let's say a1 greater than a1 mod 3 is equal to 0, and I'll print f3. So 1 2 2 3 3. So we have to understand it like this. 1 0. What is the element at index 1 0? So at index 1 0 we have 15. All the elements that are divisible by 3. So let's figure them out. So then we have 12. 12 is at 2 0. Then we have 24. 24 is at 2 2, right? Then we have 12. 12 is at index 3 1. So this is 3 and 1. This is 3 and 1. All right. And lastly we have 27. 27, which is 3 2, row index 3 and column index 2. So guys, this is how we have to perform np.where. The second type is it works as if else. So this is the second syntax. It directly returns the elements. All right, it directly returns the elements. So let's call this f4. The array that we chose to begin with was p1. Now over here I'll be writing f4. F4 is np.where p1 mod 3 equals to 0, and I need to write if this is true. So if this condition is true, I need to apply some logic. Maybe I'll shift it to 0, otherwise p1. What does this imply? If p1 is maybe divisible by 3, change it to 0, otherwise p1 means no change. P1 implies no change. So if you observe this f4, see, all the numbers which are divisible by 0 have now become divisible by 3 have now become 0. So if they're not divisible by 3, I want to let's say return 1. So wherever we are getting 0, that means those numbers are divisible by 3. Now same logic can also be extended to 2D arrays. Now instead of maybe divisibility by 3, I can check divisibility by 5. So this is f5. If the elements are divisible by 5, I want to return 0, otherwise I want to return 1. If a1 is divisible by 5, all right, change it to 0, otherwise 1. So this is f5. Now see, all the elements that are divisible by 5, we can see 0, otherwise it has become 1. So this is one way of utilizing, let's say, filters. This is how we can use filters. This is how we can filter the numpy array. The second function that we have to perform the same, that is extract. So I think this was the sixth function, so maybe we can call this the seventh one. Now extract directly returns the values on which the conditions are applied. So this is P1. Now this is filtering we have done till F5. So F6 is np dot where np dot extract. Alright, and in extract I can write P1 less than 10 or maybe P1 less than 20. So this will directly return the elements that are less than 20. And I need to pass P1 as well. So guys, just observe 12, 14, 7, 4 and 17, these numbers are less than 20. Now likewise, if I were to print A1, now I want to apply some conditions, maybe F7, and in F7 I want to write np dot extract. I want to check the numbers A1. Alright, I wish to display all the numbers, maybe that are what condition should we consider? Alright, let's say that are divisible by 5 and in A1. So I just want to filter those numbers, right? So this will give me the row index and the column index. Will it give me the row index or the column index? No, because this is an extract function, so it will only return the elements. Had it been where, it would have returned the, let's say, elements. What is it returning? It is returning the elements. So these are the numbers. Let's say I'm filtering all the numbers. Okay, I think I've made a mistake. Yes. Now, if you were to observe this example, so I want to filter out all the numbers that are divisible by 5. Alright, so what are the numbers divisible by 5? We have 5, 15 and 20. These are the three numbers divisible by 5. What if I were to write all the elements not divisible by 5? So this is what I'm getting. Right, now there's another option. If we have an array like this, there's yet another way to filter it. I can simply write A1 where A1 mod 3 equals to 0. So there is no filtering function used, rather inside the index criteria, inside the square bracket where we do mention the indexing and slicing concepts. All right, indexing and slicing logic, utilizing the same, I'm simply passing the filtering condition. So even this way we can filter out all the elements that are divisible by 3. So this is how we can display this. And lastly, maybe A1. So this was for 2D array. Okay, I'll give another condition, A1 where mod 8 not equal to 0. Alright, so these are the numbers which are not divisible by 8. Filter all elements not divisible by 8. So I hope this is clear to everyone. So this was for 2D array. We can also do it for 1D array. So for 1D array, I can directly print P1 where, let's say, P1 greater than 10 or maybe P1 greater than 30. So what are the elements greater than 30? We have 79, 32 and 45. Right. So guys, this is how we can apply filtering as well. So guys, that brings us to the end of this session. So let's switch to the PPT. So guys, in this session, we have discussed understanding array functions. We have understood the array arithmetic functions. We have discussed a couple of array functions that begins with arg, that essentially returns the index. And we have also understood array filtering functions. So in the next session, we'll be discussing about matrix related operations and broadcasting. Thank you.